This Week in Parasitism is brought to you by the American Society for Microbiology at microbeworld.org/TWiP. This Week in Parasitism, episode number 54, recorded on May 1st, 2013. Hello, everybody. I am Vincent Racaniello, and with me is the inimitable Dickson Despommier.
Dr. Racaniello, you're in rare form.
It's morning.
It is
There's
morning.
plenty of energy.
There is.
No objectionable things have happened.
Although
I must say that, in general,
Yeah.
I do not have objectionable things happening.
That's good.
Except for traffic.
Well,
Yeah, traffic is really objectionable. Today was not so bad, but
no, you're right, it wasn't.
this is an unusual time for us to be recording. It's not even 10 a.m.
I know. Take heart, though, Vince. As the price of gasoline goes up, the traffic volume will go down.
Yeah. Well, I should just take public transportation more than I do.
Yeah.
And that way I wouldn't complain.
Oh,
but all other things. You know, May Day today, right?
It is May Day, and lots of celebrations, lots of protests, lots of activity.
Only 2 more lectures left in my course.
Wow.
And then it's over. Another year is over.
Wait, which course is that, Vince? I'm not
Virology.
sure.
Sorry, folks, my virology course, which you can find at virology.ws/course.
You mean they can all be your students?
You know, I have 90,000 so far registered for this course online. Isn't that
kidding?
Unbelievable?
90,000?
90,000 at iTunes University. I find this remarkable.
That's
that
incredible.
So many people are interested in things you can't even see.
It's amazing, but you can feel them.
If I had a penny from each, I would have 90,000 pennies.
That would, let's see how
much would that be?
That's $900, I think, Vince.
I don't want a penny from them. I'm happy to do this. But I'm sad that the course is over because I really enjoy teaching. I enjoy the look of curiosity. I like nothing more than to stand there before the class and incite curiosity and look at their eyes going, wow, that is really neat.
You know what I used to call that? I used to call that light bulbs lighting up. Because those are unlit light bulbs.
And now, of course, they'd be high efficiency. What are they, LEDs?
LEDs, that's right.
Extremely expensive.
In the beginning, any new product is, and I think these are considered expensive, but they are long-lived. So over the long term, they are not expensive at all. And, of course, they consume very little electricity. So they're even more efficient in that regard. But you're right. I mean...
How so?
No, you're right. That they're expensive.
Yeah, but they last longer. Yeah. Saul, our neighbor, was complaining he just outfitted his office, his home office, with LEDs, and he had 15 or 16 lights.
Yeah.
Can you imagine? I have no room in my life with 16 lights. And so he said it was very expensive, but hopefully it will last a long time.
Well, he'll get his money back and more so then. That's what the promise of this new technology is. So
today we're going to talk about Parasites.
We are.
Because this is the theme of this show.
Well, let's hope.
Correct.
Hopefully that's true.
And since you're here, I take advantage of this.
That's right.
And we'll try and be regular. We've been not bad with the regularity, right?
Correct.
The last one we did was about saliva vaccine. Remember that?
I do. And we're being more diligent because I think together we both enjoy doing this.
I find it ponderous. Just kidding. No, I love it, of course. I enjoy learning, and as much as, you know, it's interesting, as much as I enjoy teaching, I enjoy learning. I find that teaching is learning.
Of course.
And so, what is on the parasitic plate for this morning?
Well, that's funny you should mention it like that, because we're going to talk about obesity.
Is that right?
We are.
I thought we were talking about some other weird parasite.
I think we're going to talk about Nipostrongylus brasiliensis.
Does that cause obesity?
No, it actually cures it.
Well, let's type that out. How do you spell that?
Nipostrongylus.
N-I-P-O.
P. N-I-P-P-O.
N-I-P-P-O.
Then strongylus.
S-T-R-O-N-G-Y-L-U-S.
Right.
And
another word.
Yeah.
Brasiliensis.
Brazilian.
Which might give you a hint as to where
Nippo.
they first discovered it.
N-I-P-P-O. Is it
Nippo.
Japan?
Nippo. Nippo is the common term for it that most parasitologists use that work on it.
Arigato.
Arigato.
Gozaimasu. Nippostrongylus brasiliensis. So Nippo, Japan, but brasiliensis, Brazil.
Yes.
Now, all of a sudden the other day you said to me, Vince, we have to do Nippostrongylus brasiliensis.
That's
Why
right.
did that pop into your head?
Oh, well, because of a paper you pointed out to me with it in there, actually.
Is that right?
Yes, you did. You sent me a paper, perhaps not even knowing what the parasite was, but it was an interesting finding.
I should look at that paper.
I hope you do, because right now I don't have my laptop with me.
All right. Do you think I put it in the TWiP folder?
I hope so.
What journal was it in?
Good question. As I recall, it was a PLOS journal, but I'm not altogether certain.
Well, let's take a brief pause here while we find this paper. One of the PLOS journals. Nippostrongylus. I just searched for Nippostrongylus.
Right.
Spell it again. Nippost. Oh, look at this. It pops right up in the search field.
And?
Oh, dear.
And obesity. Just type Nippostrongylus and obesity in mice, and I think you might get it. If you
just put obesity in, and there's no results.
No results.
I think we're going to do a human parasite. Is this a human parasite?
No.
No.
It's not.
No. You had said the other day some dean got infected with it here, and you wanted to do that one. Remember?
Oh, I know which one that is. We can do both. We can actually do both. That's Blastocystis hominis.
That's the one. You said, Vince, let's do Blastocystis hominis.
Sure, let's do Okay, fine, let's do Blastocystis.
Let's do that.
Okay.
Because I didn't know you were doing the Nippo.
Oh, but I wanted to talk about the difference between...
You can do whatever you want. It's your show. Blastocystis, Blastocystis. TIS.
Another word.
Hominis?
Hominis.
Hominos or is?
Is.
IS, right? Hominis. All right. Nippostrongylus is a strongyloides?
It's a strongyle parasite. Strongyle. There's a general group of those parasites.
Nematode?
Yeah. Roundworm, nematode.
Roundworm.
Yes,
would that make it a cestode?
No.
Or a trematode?
Neither of those.
What's the roundworm? Just roundworm?
Yeah.
All right.
They're nematodes. They're nematodes.
Nematode.
Yeah. In this case, it's a parasitic nematode. Remember we discussed nematodes there?
What about Blastocystis?
It's a protozoan.
I don't know if we can mix them in one episode. Is that going to be good?
I guess so. Let's do Blastocystis because there's a lot of controversy surrounding this.
We can do Nippostrongylus next time.
We'll reserve that for later.
How would that be?
That's fine, because what I wanted to really drive at in that episode, well, we won't spoil it too much.
No, don't spoil it at all.
We won't.
There happens to be a lot of material online about Blastocystis.
Of course there is, because of those controversies.
All right. Let's do the basics.
Fine.
Let's go to the basics, as they say.
Let's talk about what we know, because there's a lot about this parasite, quotes, unquotes, parasite.
Oh, quote, unquote?
It's not certain whether it is a parasite or not, because in many people it doesn't do anything.
So we're not even certain if we should be talking about it on TWiP.
No, we should, because it comes up a lot in terms of differential diagnosis for a lot of disorders which relate to chronic problems that people suffer from. I'll give you a typical example. First, let's start with a case and then work backwards, okay?
Whatever you wish.
A young male anthropology student returns from a 3-month stint in Bali.
What country is Bali in?
It's in Indonesia.
Indonesia.
That's right, Indonesia. And he's spent his entire time in the field with his mentor, studying, let's say, mating rituals of peoples that live naturalistically in the deep forest.
These are ancient tribes?
Ancient tribes that have not yet been assimilated into modern culture.
And they have no technology, basically.
Yeah, well, they have lots of technology, but it's all, what we would call primitive technology, but it serves their purposes very well.
They don't have iPhones.
They might. They all have T-shirts that say L.A. Lakers on them.
Okay. So what's interesting about studying these people?
Well, I'm not going to get to that part because I'm not an anthropologist, so I really can't speak to that issue. But I can tell you that anthropologists are particularly susceptible to a myriad of parasitic infections that they acquire by having to gain the confidence of the people that they're studying.
So they have to assimilate into their culture.
They have to
eat what they eat,
and live like they do, and sleep like they do,
because if you don't, then they're not going to tell you.
They won't accept you. Wow. So you have to become a Yanomami in order to study the Yanomami, for instance, in South America. So in these situations, they often come back with things that would ordinarily be associated with Peace Corps volunteers, which is another group, by the way, that comes back with lots of things that they never left with.
Got it.
I mean, memories are one thing, of course, but this is different, okay? So to avoid a lot of these infections, they are advised to take things as preventatives, like mefloquine, for instance, for malaria, which we know doesn't prevent infection, but it prevents disease.
And so you take it before you go, and then while you're there, you take it?
And you take it while you're there, and eventually, of course, you get sick of taking it, so you stop taking it because they don't take it, so you don't take it, and as a result, you get malaria. Okay, so the other thing you're subjected to, of course, is the fact that you have to drink every day. You have to drink water every single day, 2.3 liters of water, otherwise you will die. So where does your water come from? It comes from the same place that their water comes from. And it might come from a well, or it might come from a spring, or it may come from that muddy body of water over there that you don't even want to swim in because you don't trust it.
Can you bring a filtration thing?
You could do that, but that separates you from them.
Well, why don't you teach them all how to use the filtration thing?
Because they don't think there's anything wrong with it, and you're insulting them for actually. So you're stuck on this.
It's complicated.
It's very, very complicated. In some instances, they'll often do bodily harm to you if you. Like if you went to Papua New Guinea, for instance, there are some risks involved in that.
Sounds like a great career.
It's a fabulous career if you survive. I mean, you can write book after book after book about your experience. But, okay, so this young student comes back from his job.
3 months, right?
3 months, back to school, right? And
college, right?
Yeah.
Okay.
Let's say he goes to a great place like University of California at Berkeley, which has a fabulous anthropology group, or the University of Arizona, which has a fabulous anthropology group, or the University of Wisconsin, which has a fabulous. It doesn't matter where, because eventually some of these infectious agents will catch up to you. Some immediately, some delayed, etc. And keep in mind, there's a lot of stress in being there. So your immune system becomes compromised because there's something called an adrenal effect, right?
What's that?
Your adrenal glands start to secrete compounds under stress, which actually dampens your immune responses.
I see.
Right? Corticosteroids.
I can also imagine that your microbiome changes, your diet changes, and that puts stress on you.
Big time. I mean, big time. Okay, so this student goes to the student health service at his school.
Doesn't feel well?
He feels miserable. Why? He's suffering from dehydration.
Okay.
He's got a fever. And he's got diarrhea. And you're the doctor. Oh, my goodness. Now what do I do?
Well, I would get a good history on him.
Right. So the first thing you do is
say... That's what Harold New would do.
That's right. Or Dr. Harold Brown. And he would say, Unde venis.
Unde venis. Where have you been, or where did you come from?
Bullseye.
Is that Latin?
Vince.
Hey, let's call this episode Unde venis. How do you spell that? It's a brilliant... Dickson, you are brilliant. If I didn't know better, I'd say you were brilliant. Unde V-E-N-I-S.
V-E-N-I-S.
Is that good?
Yeah, it's a quote from Shakespeare, actually.
Oh, yeah? Let me look it up while you're talking. Unde. So the guy... It's important to get a history, because then you can say, you've been somewhere. That's what Harold New used to do.
That's what Harold
You've
Brown...
been to Puerto Rico, you may have...
That's right.
Dengue or something.
Or schistosomiasis. Or fasciola hepatica. We didn't even did we discuss fasciola hepatica? My memory is, we're up to 54 episodes now, so it's difficult to go back in time and remember everything we've ever said. But, okay, so this alert physician who had the benefit.
I searched for Unde Venice, and I get a picture of Venice flooded with water. Because it's underwater, you get it? Unde Venice. Sorry.
No, if you type out Julius Caesar, which is the play.
He said...
No, it's the play written by...
Oh, it's a quote from Julius Caesar, written by William Shakespeare.
That's correct.
Okay, Unde Venice.
Did William Shakespeare ever have a middle name?
William S. Why are you diverting?
I don't know, because I guess we're having a conversation.
It's morning? It's
morning, and I've had my coffee, and I feel good. And
no, there's no I haven't bothered you.
And
I don't see any
that's right.
middle names.
Well,
but
one of our listeners will have to know this. That's correct. Okay, so here we are at the student health service with a young...
Unde venis.
Unde venis.
So he tells him I came from Bali.
No, he's not going to say that to begin with. He's going to say...
He's not?
Where were you born?
How long has it been since he got back from Bali?
3 weeks.
Okay, I would say I was in Bali 3 weeks ago.
No, he's going to start with, what is your name? Where are you from? How long have you been in California? How long have you been a student here? Let me see your ID.
Okay.
Go see the nurse, fill out the forms, come back and see me. Okay, fine, you filled out the forms and everything else. What are your chief complaints? Mm-hmm. Chief complaints are...
What seems to be the problem?
What seems...
Typical line.
That's right. What brought you here? Why are you bothering me?
I'm just happy to see you.
Just checking back in. No. So it's very serious because ultimately he will identify the fact that he has spent 3 months with his mentor in the...
Mentor's okay,
deep,
I presume.
We don't know that. The mentor is still over there.
In the deep what? In the deep forest?
Deep forest. We won't call it a jungle.
Is it tropical?
Oh, very.
All right. So a lot of bugs, a lot of wildlife.
A lot of wildlife, some of which you just don't want to encounter at all.
How would you like to be dropped off there with a camera crew?
I watched the show. I watched the show Survivor, man. I watched that show. I'm curious as to how that guy does it all the time.
They have...
It's great.
Sustenance.
It's a great show. It's a great
nice
show.
Tent that he goes in at the end of the
day.
Yeah,
but, he's taking risks as well by eating things. And he's aware of all these things that you can catch because occasionally they do drop him off in a tropical situation. But, okay, so this student...
We're diverting a lot. I hope people don't mind.
No, it's okay because it's part of parasitic disease. This is the crux of clinical parasitic disease. Okay. All right, so the student sits down and tells the physician how many weeks or months he's been in that particular location, and of course the physician has to go to the internet and go to Google Earth and say, "Show me exactly where you were." Oh, you were over there. My God! So, physician, if he's alert,
he or she.
But
it could be a travel physician, in which case they would know exactly.
Student health services.
No, not student health. That's for sure. You'd have to go to a private.
You're going to get a resident.
Because when I went to a travel physician to get a yellow fever vaccine to go to Brazil, he knew exactly where I was
like
going.
That. Okay, so the CDC actually has a website that you can go to.
Yeah.
And you can look up
travelers'
a place. Yeah, and you can see what's there.
So right now, should you go to Shanghai, Dickson?
Right now, it depends on whether I like General Tso's chicken and whether they ask me to prepare it. If they don't ask me to prepare it, but rather to eat it, I'd go in a minute because I love Shanghai. I've been there already. It's a great place. But I know what you're driving at here.
I know. I'm just kidding.
H7N9 outbreak. So the doctor in charge of this service then. After listening to all the symptoms, takes a series of samples to send off to the diagnostic laboratory.
What kind of samples would he take, Dick?
Well, in this case, since he's got a fever,
right?
But he took his Mcqueen religiously for the first 2 days. Notice I said the first 2 days.
The first 2 days only?
Yeah, and then he started to develop these incredible, vivid nightmares.
Yeah,
and blamed it on the drug.
Could be good nightmares.
It could be good nightmares, but in this case, they weren't so good. Yeah. The take on that from a good friend of mine, Dr. Charles Knorsch, who was on one of our episodes, tells me that everybody who travels to places like that, whether they take Mcqueen or not, invariably have vivid dreams of some sort. Because you're out of your element and you're imagining things.
Well, I had a student who was going somewhere and she had to take... I don't know what it was, but she said here before she even left, I got the weirdest dreams.
Exactly, in anticipation of having even weirder dreams. Yeah. So he takes a blood sample because he suspects that perhaps the student acquired malaria on his travels.
Blood sample, okay.
So he'd send it off to the lab for malaria.
Right.
And you make a blood smear and you do a stain, Giemsa or a Wright's, and then you look under the microscope and you go up and down and you find the parasite. You say, aha! And what would it be, Vince, if it was Indonesia, for instance?
Well, which malaria would it be?
That's right. Which one?
Wouldn't be falciparum?
Probably not.
Would be plasmodium?
This is a stretch. If you get this one, I am going to bow to you.
Why?
Because we haven't only discussed this once.
Yeah.
You have a steel trap mind, I know that. So Plasmodium vivax is a common malaria.
Would be vivax in Indonesia?
Yeah, it's common. And you know what's interesting about vivax in Indonesia, Vince?
It's endemic there, huh?
No, it's drug resistant. It's the only place on Earth that Vivax has become resistant to chloroquine. Interesting. So the blood sample goes off, and you're going to wait 2 days for this result.
2 days, and it comes back negative, right?
Well, they didn't say that, but let's assume for the moment.
If it were positive, then he could have a couple of infections, though.
He could have multiples.
The thing is, Dickson, if it came back positive for malaria, he would put him on some anti-malarial.
He would.
And stop looking, right?
Maybe. Depends on the other tests.
He also sent other tests?
He had to send other tests, Vincent, because he was complaining of diarrheal disease as well.
Yeah, malaria wouldn't do that to you.
No. And dehydration.
Well, maybe he didn't drink enough, right?
Or maybe he was dehydrated because of his diarrhea. Sure, of course. So, and then he might take a urine sample just for the heck of it. Mm-hmm. So you might have a stool sample, a urine sample, and a blood sample.
What are you going to look for in the urine?
What would you look for in the urine? I wouldn't look for parasites. I would look for chemical alterations.
Oh, yeah. Which parasites would be in the urine?
As far as I can tell from my own...
What's the one that we talked
about?
Well,
trichomonas could be there.
Causes the bladder problem.
Oh, that's schistosoma hematobium. Yeah. It's not found in Indonesia.
Okay.
So you wouldn't...
But you see, I did remember that.
Yes, you did. No, that's great.
Blood in the urine.
Okay,
right?
the parasite actually isn't in the urine itself, just the eggs of the parasite.
But it makes it bloody, right?
It does. It can lead to bloody urine. But, okay, so... but there are other things that can infect the bladder, or at least the ureter.
Got it.
So you could look for that too, but that's not his chief complaint. His chief complaint, he doesn't have urinary tract bleeding, he doesn't have urinary tract burning upon urination, he doesn't have those symptoms, so he's okay there. But he's got this diarrhea, and he caught it like 2 weeks into his trip, and he can't seem to shake it. So every third day or fourth day, he has these...
Giardia, right?
Loose...
That wouldn't last that long.
It might.
Could?
It could. Of course it could.
But you find it in Indonesia?
It's worldwide. You can find it everywhere. But the point is that he's got this adrenal effect of just being stressed out by being in a strange place.
How would you know he's got the adrenal effect?
Because he's stressed out, Vince.
Would the doc pick this up?
Sure. Anybody who spends that much time in a strange place and just a student without too much jungle training, too much deep forest training, being thrown into the mix, so to speak, with his mentor to study a tribe that's expecting him to behave like they do.
Yeah, it's stressful.
They're very stressful. Of course it is. But he's very excited about this, too. By the way, I mention he was a graduate student? Okay, so you don't have undergraduates that do this. This would be a graduate student. So he sends the stool off, okay, and the urine off for just chemical analysis to see if he's electrolyte poor, to recommend, maybe start drinking Gatorade or something like that. And the bloods come back negative.
Right.
And the stool comes back not parasite-free, as they would list it, if it didn't have anything in it. It comes back with only one thing that can be recognized. It's not normal for stool.
Okay.
One thing.
One thing.
One thing and one thing only. And it comes back many Blastocystis hominis seen.
In the stool.
In the stool.
And what would they look like?
Well, for many, many years, they were confused for yeast. And if you look them up on Google Images, you'll see that they have a very large storage granule and a very small rim of cytoplasm.
Is this in your book, by the way?
It is, actually.
Well, let's get it.
Okay. Sure. But it's not under parasites. It's in the back of the book in the Diagnostic Atlas.
Could you find this quickly?
I could if you just
give it to you.
Gave me the book. Sure.
It's not in the main narrative.
It's not in the main. It's in the main narrative under
not medically important.
That's right. Here it is. Right here. So it's totally indescribable in terms of its morphology. I mean, it was often passed over by technicians. Parasitic technicians.
Yeah. So we should put this picture in.
Yeah, sure. And there's tons of them. I mean, and they've actually been able to culture this thing now. It's an anaerobe.
You have an index in this book?
I do. In fact, I did the index of that book.
How much were you paid to do the index?
0. I wasn't paid to do this book at all, Vince.
Are you doing it again, by the way?
We might be. We might be.
Sell this. I spent hours putting this in an e-format. What happened to that?
I'm using it right now, in fact. It's a wonderful...
99, 100, and 317. Okay, I think 317 is what you just showed me.
Yeah.
Let's see, 99, 100.
99, that's right.
Oh, it's in the protozoa. Here we go.
It's in the protozoa. It turns out to be a protozoa.
You know, there are some others here we should go over.
There it is.
Okay?
There are.
All right, here we go. Blastocystis. It has a picture in the main book.
It does. Now,
let's continue with this diagnosis. So they see it in this kid.
Right.
Lots of Blastocystis hominis.
Lots of it. Nothing else. And so the physician sees a red flag go up and says,
But they know it's Blastocystis? They could identify it in the parasitology lab? Yeah.
Today, everybody diagnoses this. So they're familiar with it now because it has a reputation.
You find it in normal people, healthy people?
We're going to go to that.
Okay.
But meanwhile, they've got this poor kid who's still suffering from diarrheal disease.
Yeah.
And they can't pin down the cause. So what else should they have done, Vince? Or what else did they do?
Wait, before he left the office?
What are the causative agents for diarrhea?
Viruses.
And?
Bacteria.
And?
Protozoa.
And? Helminths.
Helminths, okay.
You got a whole bunch of things to look for, right? So
well, they didn't find them in the stool, right?
They didn't say that. No, I didn't. I said when they looked, they only found one thing that they could identify different from a normal stool.
Blastocystis.
But would you see salmonella if you saw it in
No,
the
you
stool?
wouldn't see it.
Would you see any rotavirus if you saw it?
No.
Right. So they had to go back and...
But the rota wouldn't last for 2 weeks.
Right.
So we could probably rule that out.
Even with an adrenal effect?
I don't know, but I don't know of any 2-week... I mean, you can shed for a while, but not with disease.
Maybe he caught it just before he came back.
Maybe.
So there are those possibilities. So they also sent the stool sample for culture, thinking maybe there's Shigella, maybe there's salmonella,
right?
Maybe there's other things, maybe some new organisms that we never even heard of.
I don't think that falls into the purview of most physicians. They don't want to have new things.
No, they sure don't.
Diagnose you and get you home.
Sure don't. They sure don't. But
get paid.
So all those tests came back negative. Actually, there was one more thing that they saw.
I think this is a real case, it sounds to me.
Believe me, as a technician and as a person who hung out in the diagnostic lab a lot and listened to the physicians talk, this is the thing that drove them crazy.
Valentidium? No, sorry.
No, stop. We haven't even talked about Valentidium. Where'd you get that word from?
I saw it on the previous page.
Vincent, I think you've been reading too much.
No, we should. I was going to say we should do some more of these parasites.
Well, that's the problem. Are they parasites?
All right, well, keep going with this guy. Now you have my attention.
Oh, thank you. I hope I have everybody else's too, but I know we're dancing around the pole here, trying to come.
But this guy was sent home, right?
He's in school.
And the doc didn't give him anything and didn't come up with anything.
Well, he has to wait for the tests.
Well, then he found Blastocystis, so what would he do?
Good question.
He would look at it and give him a drug?
Nothing yet.
Nothing.
He's waiting for the culture tests to come back.
Of the stool. Yeah. All right, so they come back. What do they say?
Negative. They're all negative.
Oh, negative, okay.
No. There is one thing. He does have a different strain of E. coli.
Yeah, which one?
It's not a 157. No. It's not from animal sources. It's from human sources. He's had a change of microflora.
Yeah, he went to a different place. That's not surprising.
No, and he's got what the doctor thinks. He's got traveler's diarrhea.
Well, that's E. coli.
That's right.
You know?
That's right. So that's his diagnosis. Now, would you treat? You're the doctor.
I don't know.
Wait a minute. I'm
not a doc, man.
Well, you're something. You're a PhD.
I wouldn't make any treatment decisions.
If you came back from a foreign place with diarrheal disease and they identified the only thing different was an E. coli strain that's not yours, what does that tell you?
I would make sure that strain was associated with diarrheal disease before treating.
Or the fact that you've got somebody else's E. coli probably means you have somebody else's other things too.
Somebody else's?
You have been exposed.
All right, so you drank or ate something
plethora
contaminated.
Of human feces.
So this is where the Blastocystis probably came from.
Well, we don't know that but he never had a stool exam done before he left.
Could he have had it before he left?
You betcha.
Really?
As we will get to.
I can't ask you the question now.
You could do that.
Like if you just screen the population of
Your
the
Honor.
U.S., how many people would have Blastocystis in their feces?
A very high percentage. A surprisingly high percentage.
That's very ambiguous. Very high. What is the number?
I can't give you a number, Vince, because I don't think modern... Let's go to the internet.
Modern
I think we should
medicine.
go to...
Let's go to the internet.
No, go to the Centers for Disease Control's website.
All right, here's the number. 5 to 10% in most developed countries.
That's a huge number.
50% in less developed areas.
Tell me how many people that is for the United States. There are 300 million people living in the United States. What's 10% of 300 million?
It's 30 million people.
30 million people!
Yeah, but they all have toxo also, don't they?
Yes, but wait a minute. What is that? Your Honor.
having
please direct the
microbes,
the witness to stick to the subject.
In your stool.
Focus.
Hey, this isn't court, man. Having microbes in your stool.
It's a little bit like court. It's a little bit like court because we have to stay on the subject here.
Okay.
The subject is, what do I do with the diagnosis of Blastocystis hominis?
Well, you have to make the kid better. That's the bottom line.
You do, but you have to figure out what's wrong first.
All right.
So now you know the most truthful statement you can make about this individual,
right,
is that during his trip to Bali, he encountered other people's feces.
Correct.
And
or
became
something contaminated.
His microbiome became compromised.
I don't know if you could say that.
Yeah, you can, because
he's got a different E. coli.
Their E. coli beat your E. coli.
That's one thing. Plus, he has blastocystis, which we know is in a lot of people without disease.
And he could have had it before he left.
Right.
But the point is, he's suffering from diarrheal disease right now.
Okay.
So you have to find a cause for that.
So do you treat him with antibiotics?
Well, which antibiotic?
With the doc, treat him, I don't know, to get rid of this weird E. coli.
I think a good physician...
Give him probiotics.
Keep talking.
Yeah, give him some
yogurt.
Didn't he store his microbiome before he left? He can just take it back. Why are you laughing?
I am.
It's going to happen one day.
No, I'm telling you that that's not a bad idea, actually. As long as everybody survives, right?
You can't. Yeah, it's very hard because you can't culture them, obviously.
No,
you can culture the ones you think are important, but that's
right.
not good
It's
enough.
1,500 different species so far, so that's too much to ask, I think.
Right,
so the infectious disease doc, who's seen a lot of GI disorders in his brief period as the student health officer for the UC Berkeley campus. So a lot of people travel, they come back, they have diarrheal disease, they go to him. He takes some tests, he gets some results, and he does some treatment modalities, right? And he says, traveler's diarrhea will disappear the moment you come back from your trip and start replacing their microbiome with the Berkeley-specific microbiome.
Well, clearly this didn't happen in his case.
No, he's just back from his trip, so the doc might say, it takes a little more time for this to develop. Come back in a week. Things get worse.
They get worse.
Right now, there's nothing in your stool that I can point to that would require treatment because 10% of the general population of the United States has this organism, and nobody is suffering from diarrheal disease like you are, so therefore, this organism mustn't cause your problem.
I'm not sure that's a correct conclusion.
50% of the people in less developed countries have this. Do you mean to tell me that 50% of the people in less developed countries suffer every day from loose stools?
No, but maybe a fraction of them do.
No, say yes. Say yes.
They do.
They all do, yes. Correct. The normal stool pattern in a person living in a less developed country, for instance, in the tropics, is 5 to 8 stools per day.
That's a lot. Are they well formed?
No.
I think you mentioned this before.
I did.
They're loose, right?
Correct. So they don't know what a formed stool is. They have no idea of what that means.
It should be formed. That's normal, right?
It is for our country.
Is that a Western stool?
It's a Western stool.
But what's the right stool for a human?
Depends on where you live.
Yeah. So these people who have 5 to 8 poorly formed stools a day, that's a lot of time to spend in the bathroom or wherever.
They may be suffering from diarrheal diseases caused by any number of things, right? So the point that's raised by this organism is this conundrum of trying to pin a sign and symptom on it, or symptoms, a constellation of signs and symptoms, without direct proof that that's the cause. Okay, so the direct proof would be what?
Direct proof of what?
That Blastocystis is causing his problem.
Koch's postulates. Right?
Work it in reverse.
You reproducibly isolate the organism from the sick person. You can culture it and you put it back in an animal that causes the disease, right?
Yeah.
But you can't do that with people, obviously. If you had an animal model, you could infer it.
It's called hominis for a good reason.
Hominis.
Humanus.
Doesn't infect any other animal.
Apparently not.
Well, the problem is that it's in a lot of healthy people, so that makes it very difficult.
Exactly right. So that's...
But if you could eliminate it from sick people and showed that they get better, that might help.
There you go.
Right?
So if you had a specific treatment modality, as they would say, if you could use... Remember, it's an anaerobe, so what drug choice...
I don't think we actually mentioned that.
We did.
It's an anaerobe?
It is. In passing, I've mentioned it's an anaerobe. But so we have two other anaerobes to talk about. We have Giardia Lamblia.
Yes, right. That's right.
And Entamoeba histolytica. Both of those parasites are protozoans. They live in the gut tract. They cause disease. And they're treatable with a drug called metronidazole, which interferes with anaerobic metabolism regardless of whether you're a protozoan or a bacteria. So the logical approach to this would be to use metronidazole to treat Blastocystis hominis and see what happens, right?
Yeah.
What happens, Vince?
It's not effective.
Correct.
I'm reading it in your book.
That's right.
There's another drug that was effective.
Called?
Nitazoxanide.
Nitazoxanide, right.
Nitazoxanide, remember?
It
shows promise.
It shows promise.
This is an old... Want me to look it up?
Yeah, go to the medical letter, actually. I'm not familiar with what the current medical letter shows as the drug of choice for blastocystis, but I bet you it's still controversial.
No, nitazoxanide is good for tapeworms, it says here.
How about that? But not for Blastocystis hominis.
Cryptosporidium, Giardia.
Go on.
It's in phase 2 trials for Hep C. Can you believe that?
Yes, I can. Go on.
Let's see.
I don't hear blastocystis.
Rotavirus. This is crazy.
I don't hear blastocystis.
No.
It's not there. Is that medical letter you're looking up?
No. Why would I look at medical letter?
Because that's an august body of clinicians that meets once a year in Westchester to produce...
Westchester, New York?
Yeah. To produce a booklet on antimicrobial therapies and their recommendations. And it's a group recommendation based on literature and experience. And it's a really fantastic one. In fact, it's reproduced in the back of my book. So if you went to the medical letter and you typed out Blastocystis hominis...
Right, I'll go to the medical letter.
You're going to get the latest recommendations from the clinical world as to what to do about blastocystis.
Well, do you think that this physician...
That's what they do.
Would have done?
You're doing exactly what they do.
Really?
Yeah, because they don't know. How would they know? They have so much to keep track of.
Blastocystis hominis did not match anything.
They probably took it out because they didn't know what to do.
Yeah. Nothing.
No, nothing.
Wow.
So,
that's a real result? There's nothing in the medical letter?
I'm afraid so.
Wow.
I'm afraid so. So here we have...
Let's do a control. Trichinella?
Oh, you'll find it there.
Now there's no trichinella. That's not possible.
No. Then that's not the medical letter, then, is it?
It says the medical letter online, trusted drug information since 1959.
Right. And it doesn't talk about trichinella or...
It didn't have trichinella malaria.
If it doesn't, well, then you're...
Yeah, it's plenty for malaria, but didn't have any for trichinella.
Or blastocystis.
That's
remarkable.
Just put in Giardia.
That's there.
Yeah, there's Giardia.
So
Here's
let's...
the blastocystis
look,
page.
Do you see this right here?
The medical letter, yeah.
They allowed us to reproduce it. So in there, if there's no blastocystis, it's because they threw up their hands and said, we don't know.
Well, I certainly don't have it here. Yeah, here it is. Drug of choice. See footnote 16.
Yeah.
Metronidazole.
Forget it.
Iodoquinol.
Forget it.
Trimethylprim.
Forget it.
Why are you saying forget it?
This was written in 19...
Nitazoxanide has been shown to be effective in children. But the most recent...
What's the date on the medical letter in the book?
2004.
What's today's date?
Yeah, it's 2013. It's a long ways.
A long ways.
And online, they don't have it. So
and that means...
so it can't be treated, basically.
Correct. Well, it hasn't responded to any common drug that we've used. Do we know another organism like that we've already discussed?
A parasite?
Mm-hmm.
That doesn't respond to any...
number one parasite if you have a HIV/AIDS.
What? Cryptococcus?
You're
Cryptosporidium?
Close. Yes.
Cryptosporidium.
There's no drug for that, Vincent. There's no drug for it. We don't know how to treat it. It just goes away in normal people.
So will this guy recover, this student?
Let's talk about that, because what we're really talking about here, without mentioning names, is a relative, a daughter, of a faculty member here at Columbia University that I was quite familiar with and friendly with.
Mm-hmm.
And he was one of our stellar administrators.
You have to be careful. You're giving away identifying material.
I'm not going to mention his name. But he became a good friend of mine.
So this was a daughter and had this syndrome that you've discussed.
That's correct. And she had chronic diarrhea.
After coming back from overseas.
She didn't go overseas.
Really?
That's right. Remember, 10% of us have it too. They don't have to go overseas to catch it.
What? Catch what?
Catch Blastocystis hominis.
I understand. You catch it from other people, right? Is that the reservoir?
That's the assumption.
There's no animals in nature that.
And there's no cyst stage to this either.
Okay, do we know the life cycle?
We don't.
It's not in your book, that's for sure.
No, it's no life cycle. It's
you
just
can't study it.
Direct contamination with another person.
Do these things multiply?
Yeah.
They just divide by binary fission, right?
They have their own unique...
So there's no sexual stage?
Not that we know of.
Okay.
In vitro, there isn't.
Now, this young lady just spontaneously developed diarrhea and dehydration, I presume?
Yeah, associated with it.
And she felt lousy. Did she have adrenal syndrome? Yeah.
Well, I don't know. Maybe she did, but she went to the...
Blastocystis was found in the stool.
It was the only thing they could identify.
Not a weird E. coli.
Not a weird E. coli. They cultured everything. They looked multiple times. All right, so let me just back up and say one more thing about this. Because we talked about this early on in our TWiP experience, but we'll revisit that now. If you're a good clinician, and I assume that everybody out there that's listening now that's a clinician is a good clinician, because why else would you listen? Bad clinicians wouldn't care about this information, so only the people that really want to keep up to date would be out there, right? So if you're a diligent, good, and diligence is the definition of a good clinician, by the way.
Mm-hmm.
That's the only definition. You don't have to be the first in your class. You don't have to be the most clever person in the world.
I agree. Yeah.
And all you have to do is be diligent. You have to have humility that allows you to ask for help. And you have to accept that help once it comes. And collaborate and consult. And those are really the hallmarks for a great clinician. A great, not just a great clinician has no ego.
Right. Also, great scientists should have no ego.
Yeah, that's
many of them do.
Different. No, because if you think you know what the answer is, in other words, trust medicine, don't trust physicians.
Yeah, but you have to trust your physician.
You do have to trust your physician. So
different.
Your physician has to rely on other physicians and scientists too for the base for their knowledge so they can treat with a science-based medicine. All right, so we're doing science-based medicine now. We're trying to come to grips with a organism which may or may not be a parasite depending on who it infects.
Mm-hmm.
So here we have Blastocystis, and I'm so happy that we've got this episode because this is the part that drives everybody crazy. It drives the patient crazy because they don't get a definitive answer back except for what they have. The technician is driven to madness because they think there's something else there causing this disease, but all they can see is blastocystis. All they can see is, that's all I can find. I looked for everything else, and it's hard to look for everything else. But it's not hard to look for everything else if the clinician is diligent. So this was a one-time only thing. The kid comes in, he's sick.
Mm-hmm.
He gives his specimens. He goes back to his dorm room or wherever he's living. He's a graduate student, so he's probably living off campus someplace. And he's trying to read, and he's trying to recover his life. He's trying to come to grips with all of his experiences. He's writing up his notes. He's got his digital camera images of all these people's behavior. But he's sick.
Mm-hmm.
He wants help. So he comes back the next day, and he bothers the clinician. He says, the results aren't in yet. I'm sorry, we can't help you yet. Okay, but doctor, I'm really sick. I have to have an answer here because I need to get back to my life. Okay, that's a big problem. So he goes home, and he waits another day. And he comes back. Your malaria tests came back. They're all negative. At least the fever that you have isn't due to that. Oh, and by the way, doesn't have a fever anymore either.
But he still has diarrhea.
It was a travel fever.
Okay. But he still has diarrhea, correct?
He actually was now suffering from constipation. Hasn't gone in 3 days.
So he's no longer dehydrated,
He's been
right?
drinking lots of fluids. His appetite has returned. He's gone to the local whatever.
He's fine now.
By the way, Berkeley has amazing street food. Amazing.
Really?
Amazing carts that sit outside of
I didn't get a chance to see
Say they're
it.
Square. They're fantastic.
I was only there like a day.
There's a restaurant there called Ay Caramba. I don't know if it's still there. I had the most wonderful Mexican burrito that you can possibly imagine.
I went to La Note.
But if I had diarrheal disease, I would not in a million years eat a burrito because, that just plays into the hands of the microbes that are causing the problem. So this guy, now he's in his third day, comes back, and the physician has a big smile on his face. He says, I think we found your problem.
Blastocystis?
And he says, Blastocystis. You've got Blastocystis hominis. That's all we can find. The tests for the culture are still pending, but nothing has turned up yet, except for this little bit strange E. coli strain, but that's not the problem here. That's just traveler's diarrhea. That's going to go away soon. But really, what I think your ultimate problem will be is this little organism over here. I've looked it up on the internet. It says that occasionally in some people it can cause disease, it can cause diarrheal disease, but that's the good news. So there is some bad news with this one.
Can't treat it, right?
He's looking at me, well, doctor, will I ever play the violin again? And the doctor says, well, yes. He says, that's strange. I could never play it before. So that's a bad joke. That was the first I heard that joke on the Muppets, by the way, which I love. This graduate student is looking at his doctor for advice and help, and the doctor says, this is all we know.
And there's no drug.
Well, there are plenty of drugs. None of them work.
Would he give this kid a drug?
He says, well, we can try metronidazole. We can try it. What will this do, though, Vincent? Remember, it treats all anaerobes. Any anaerobes living in your gut
Even
tract?
bacteria?
Oh, yes. Doesn't matter what.
Okay, it'll mess up his flora.
Of course it will. It's going to screw up his microbiome like you wouldn't believe. But they give it anyway because it's the only drug they can really...
All right, so he's giving this kid metronidazole.
He says, we'll try...
All right, what happens?
Nothing, of course, nothing. Well, no, his diarrhea
But he gets constipated from the metronidazole?
No, he's constipated.
Before?
Then a week later, he's back to diarrheal disease. It's a cycle of constipation and diarrhea. It's never normal.
Before this kid was sick, did he have blastocystis in his stool? Probably not.
We don't know
Can
that.
you take the blastocystis and type it to a Bali blastocystis as opposed to a U.S. blastocystis?
I don't
That would
know.
probably help, wouldn't it?
It might, but what difference would it make? You still can't.
He got it in Bali and didn't have it his whole life before. Maybe I have blastocystis and I'm fine.
But just, right.
Should I look?
No, all of these are valid questions. There are no valid answers.
Well, there should be. What are we waiting for?
I'm trying to tell you something here.
I understand.
I'm at the edge of my frustration level here because just like that student, I think you want the same answers. You would love me to say, oh, and by the way, there's been this breakthrough.
No. I understand there's no answer here, but I'm trying to get at all the information that we can get.
Right. Now imagine if you just substitute the word cryptosporidium for blastocystis, you've got exactly the same situation in AIDS patients.
Do they have crypto?
They can catch crypto because their immune system is compromised.
Right. Does it make them sick?
They can die from it.
Yeah, there's one of the opportunistic infections you're saying that they get?
Yes, it is.
Of course.
Yes. And
you treat it?
They have tried with everything in their power to treat this infection.
Is it an amoeba?
No.
What is crypto?
No, it's an epicomplexa.
It's not in this chapter.
Yes, it is. It's related to malaria.
Okay, go ahead.
And so...
But you can't treat it, you're saying?
You can't. Oh, you can treat it, but it doesn't work. Whatever drug you've used against this infection has failed. Spiramycin. They've gone to every single antimicrobial therapeutic that exists on the planet, and nothing touches this infection. You know why? In this case, it's because it lives intramembranously inside of a membrane that it creates for itself. Yeah, and the reservoir hosts are common domestic cattle and animals.
Cryptosporidium hominis, just like Blastocystis hominis.
That's correct.
Let's see how you would.
They're not related. They're not related,
just
but they
came from hominis.
But
Prevention and control.
Yeah, right. Prevention and control is different. Treatment is the crux of the matter.
Nitazoxanide.
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 It's not effective.
appears to be not effective when used to treat infections in AIDS patients.
That's correct. Those are the only people you want to treat because everybody else,
sure.
everybody else, believe it or not, Vince, cures themselves.
So there are no carriers.
Didn't say that.
So people that have it a long time, they don't get sick, for example.
Right, exactly right. Wow. So here we got, let's just come back to blastocystis, though, because these people can have this infection for their lives. It doesn't go away.
And this has been documented that people shed it.
10% of us have it.
But I just don't know if they go back and check the people over and over, you know.
Well, I'll tell you what happens in this case. Here's this student, and he's now been told by his physician that there's nothing further that we can do for you.
Yeah, and he's very frustrated because he feels lousy.
He's not just frustrated. He's angry.
Yeah.
He's angry. Why is he angry? Well, he's angry because, A, he caught something. He's angry because he's at the height of clinical Western medicine and they can't do anything. So what is the alternative? Maybe there's a secret treatment that we're not aware of that the people living in Bali's forests use to get rid of this thing. So maybe I'll start.
Medicine, right?
Well, I wouldn't call it folk medicine. I would call it traditional medicinals.
We want to be politically correct, don't we?
We want to be correct. So, if this was the 1500s.
So does he go back to Bali?
Wait a minute. I want to make a side issue here. If this were the 1500s and you were the Spanish and you had come to the New World and you were fully aware of the fact that you could catch malaria, not just in the New World, but back in Europe too. There was tons of it. And you see a people living in a place where everybody should have had malaria and there's no malaria.
They're eating some plant, right?
Or they're eating something, that's for sure.
Yeah, so you talk to them about it. You figure it out. So this guy should go back to Bali.
The Spanish conquistadores said, don't kill all those people yet. We have to find out what's protecting them from malaria, and then we'll kill them.
No, well, actually, the diseases they brought
That's what they did.
Vince. They didn't kill all of them.
They tried.
The viruses that they brought killed them.
That's true, but they did kill a lot of people, too.
Well, they were outnumbered.
That doesn't mean anything.
100 Spaniards?
They never tried
no
to
way
make
they
friends.
Could kill.
They never tried. Oh, I see what you mean.
It's just the viruses they brought.
You're quite right. And,
anyway.
and the bacteria. Don't forget the bacteria.
Those two?
Sure. So, one of the queens of an Inca province shared their secret with him. And it turned out to be, as we've discussed, the bark of the cinchona tree, which contains quinine. And quinine is the cure for malaria, at least it used to be.
Right.
So they took that back to Europe, and that's where the rest is history, as they would say, because the Brewers Welcome Company came into existence. They made more money selling quinine than any other drug.
But what
in
about
history.
Blastocystis?
What about that? It doesn't respond to that either. So,
what about
maybe
if you go
someplace,
to Bali and ask them, why are you not sick?
No, that's a good question.
But they do have diarrhea, you said.
It's normal.
They don't feel badly?
They'll look at you and say,
it's normal?
What's wrong with you? Nothing. You're just like us now. You've been assimilated into our culture because you now have 5 to 10 loose stools a day. So you have to keep drinking more. And it's
maybe he needs to go on a drinking bout and get rid of the blastocystis.
It's a vicious cycle. So this particular individual who I referenced as being a relative of a former faculty member here, this individual lived, as far as I know, for the rest of their lives with this infection.
Wait. You said with this infection. You're not sure if it's an infection.
No, it's an infection.
But we don't know if it's causing.
Right.
So it was periodically sampled and
it's
it was
an
still
infection,
present.
But it's not always causing disease.
Was this patient always sick? Was the patient, you said it had cycles of diarrhea and normal stool. And that happened the rest of her life?
Which drives the epidemiologist crazy in trying to pin down whether or not it's a pathogen.
So this person never got well?
Never got well. Well, that doesn't mean that they never got well. They went back to normal weight. The fever went away, but the one thing that they've always had after that is loose stools. They've never had formed stools after that. They've either had
those stools always have blastocystis in them.
Always. Wherever they've gone with their stools, maybe they've misdiagnosed it, or maybe another lab has a better take on this, or maybe this doctor has. Sure. And eventually you're into folk medicine and quackery and all kinds of other weird behaviors, thinking, well, maybe they've got a cure for this.
Wow. So,
do you remember Steve McQueen? Do you remember Steve McQueen?
Well, I didn't know him, but I know he was an actor, but he's dead.
Do you know what he did?
No.
He went down to Mexico.
To do what?
To get a new treatment that no one would give.
Oh, he had cancer?
Yeah.
Yeah.
What did they treat him with?
I don't know.
An extract from the pit of apricots.
Okay.
I forget the name of that drug. Of course, it didn't work. It was quackery.
Yeah,
but he was at the end of his rope. Yeah, you could find out what that is. I forget the name of that drug.
Letriol.
Yes.
Right. Let's say, Dickson, you had an illness and it couldn't be cured. Would you resort to quackery? I would not, since I'm, kind of a student of the medical sciences.
But look at us. We do TWiP together, too. And what big problem came up on TWiP that eventually resolved through science?
Yeah, the supposed causative agent of chronic fatigue syndrome.
That's
right?
correct. Or whether or not vaccinations caused autism. Did you watch the show last night, by the way? We had a wonderful... This is the anniversary of the establishment, I guess, of official science-based... There goes an AWACS out the window.
Wow.
AWACS. That's an AWACS. That's an AWACS.
It is. It's got the big disc on.
Yep.
We're referring to a plane flying by the window.
You're right.
Wow.
So, I was right. So science-based medicine will come to the rescue here.
Yeah, but it can't always.
It has to always. It has to always. It can't make an exception.
I know, but in these cases, we don't know what the problem is.
So
we don't know how to treat it. We're still looking.
So you can
and there are many
it.
diseases that are like this, Dickson, not just this one, but all kinds of cancers we can't treat.
Aren't you glad we brought this up, though? Because
that's a great story. I think
up to this point,
it sounds like everything
pretty straightforward.
Yeah, we can deal with everything,
but
right?
That's not straightforward.
No, and this is probably the norm, right?
That's right.
And would you say that most problems in medicine cannot be taken care of? I wouldn't say that.
Here's what I would say.
I think there are a lot of problems that cannot be, but I think that many others are dealt with. No?
You've got two kinds of problems, right? You've got acute problems and chronic problems.
Yeah.
Take the acute problems. Science is extremely good at dealing with acute problems, right?
In many cases, they
heart
go away.
attack, stroke.
Oh, those things. In fact, I'm thinking of acute infections,
No. I'm just thinking of acute disease, regardless of whether it's infectious or not. We're very good at taking care of emergencies.
Mm-hmm.
And we pride ourselves in the fact that we can intervene with someone's life to save it. Chronic problems, let's take the most common chronic problem. What do you think it is?
Wait a minute. The most common chronic problem worldwide.
Yes.
I don't know. Outside of infections?
It's arthritis.
Is that right?
Arthritis.
It's not heart disease or diabetes.
Nah.
It's arthritis.
Yeah, arthritis.
That's a chronic problem.
Absolutely.
Do you have arthritis?
I do.
How does it manifest?
Joint pain, right?
Always?
Immobility. I'm trying to make a fist.
No, you can't close your fingers.
I can't close this finger. I can close my other fingers.
Yeah, I can close. I don't have any joint pain.
Not yet. Well, you're too young.
Too young? When did you first get this?
When I was about 65.
Okay.
So it's chronic, and it's a consequence of living long. So
we're supposed to be dead by 40, right?
That's right. The Earth is living longer. So what is the most common chronic problem? It's arthritis. So how do you treat it? You don't.
There's nothing to do? People are working on it, right?
Of course they're working on it, but the COX-2 inhibitors were the first group of real promising drugs, and what happened? People started to die of heart attacks. So they took it off the market and said, nope, that's not the treatment. Although it was really good for chronic arthritis, it also kills you.
There's another company that still has one of those inhibitors on the market.
Yeah, right? I know. So the aspirin or ibuprofen or some palliative medicine which cures the pain but not the cause. So that we're stuck with this. We don't know how to deal with chronic illnesses. We know very well how to deal with acute illnesses, like infectious diseases that cause symptoms that you can treat.
We're starting to be able to deal with chronic infections like AIDS and hepatitis C, right?
Well, yes.
We can treat AIDS so that you are not sick your whole life. You take triple antiviral therapy.
Yes.
There are new drugs for Hep C coming along, which
I would call AIDS a delayed
acute infection.
Yes,
that's
right.
an interesting. I was talking about that in class the other day.
Yeah.
There are some people who think it's an acute infection with a long incubation period.
That's what it is.
No, I don't agree, because the virus is latent within you. It's in your genome. You're stuck with it. An acute infection comes and goes. and HIV never goes. You're always stuck with it. So by that reason, I call it a chronic infection.
Apparently, they've got a way of chasing it out of its hiding place.
I saw that, Dickson.
What did you think of that, by the way?
Well, so what they're doing is using inhibitors of histone deacetylases. These are enzymes that take the acetyl group off of histones. It makes it more compact, and it shuts down transcription. So the inhibitors will allow transcription to occur, and the idea is that you treat latently infected cells, you get the virus to grow, and then you kill it with antivirals.
Sure. Do you know of a parasitic infection like that?
No.
I do.
What?
It's analogous. It's not identical. With toxoplasma is like that.
Mm-hmm.
When it's in the brain tissue, it's not dividing at all. There's no drug that will touch it because it's not doing anything.
Can you get it to divide?
Yeah, you can inhibit IL-12.
So anyway, you asked me what I think of this. Well, I asked Kathy Collins at the University of Michigan, who studies the reservoir of HIV in long-lived hematopoietic precursor cells.
Okay.
And she is not sure that it will reactivate the virus in every cell.
Mm-hmm.
If it misses some,
well,
you miss one
is enough.
It's not enough.
That's correct.
So I'm not sure it will get rid of it. Now it's going into some clinical trials, and we'll see.
Yeah.
But I think it's not the answer because you have to get every one, and that may be a problem.
It's too iffy. All right.
All right. Interesting story.
Yep.
Is there anything we missed?
Well, there's probably plenty that we missed, but
I get the picture.
We hit the main points.
Telling a story and teaching something. Want to do some email?
Sure.
Tommy writes. Tommy is our friend in Australia who we need to do a TWiP with. We have to be able to start at like 5 p.m. Eastern time here. Okay?
Okay, sure.
And I know you run out of here at 5 exactly.
Vince.
But one day we will set it up, okay? Because he's an interesting guy.
I like that.
Hi, Vincent and Dickson. I was listening to the new episode of TWiP 52, and one of your listeners wrote in asking about tree parasites. Remember?
Yeah, sure.
You didn't know anything about it.
Nope.
And if you don't know, I certainly don't know. While plant parasite is not my main field of research, I have written about one such parasite on the Parasite of the Day blog, the nematode Bursophilencus xylophilus, which causes the tree disease known as pine wilt. So he provides a link to his Parasite of the Day story on that. Pine wilt.
Let me correct myself in the sense that I do know of some tree parasites, but they're large parasites. Okay, the epiphytes.
Okay.
That grow on trees like Spanish moss.
Yeah.
Those are parasitic.
The basis for that post was actually a PLOS Pathogens paper on the genomic characteristics of that particular parasite. In addition, there are also numerous insects, nematodes, and bacteria that can infect plant tissue and induce gall formation.
Exactly.
I feel that Dickson might be fond of those plant parasites because much like Trichinella spiralis, these organisms are capable of manipulating the architecture of the host's tissue, forcing it to grow structures that both house and feed the parasites, much like T. spiralis with its nurse cell.
Wow.
Do you like that?
I love it. Yeah, sure.
Thank you,
and there is one predator of trees.
Humans.
No. The tropical fig tree.
Oh, yeah? Who's that?
It's ficus. It's a ficus. So here's what happened. I know this is an aside, but it's very interesting.
It's okay. People love it when you go aside.
Okay, fine. So fig trees, if you look at the canopy of the tropical rainforest, particularly in Brazil, from the air, you can actually pick out which fig tree is in blossom of all the fig trees. And they don't blossom all together. They blossom one at a time.
Okay.
And as they blossom, of course, the next thing they do is produce fruit.
Right.
And figs are the favorite of...
bats?
Yes. And...
sloths?
No, I didn't make
chimpanzees?
Well, they don't live in South America.
No, it's a New World monkey.
They're very, very fond of figs. Okay.
What are they?
The New World monkeys.
Oh, New World monkeys.
Right,
okay.
You just said it. So they follow their nose to the blossoms, and they sit in that tree and they wait for the fruit.
To do what? To mature?
To eat. Okay. Sometimes they do that. Other times they find the fruit, but if they don't get there first, of course, it's all gone.
Okay.
So a monkey sits in the trees, eats the figs. Now, anybody out there that's eaten figs knows just like Blastocystis hominis, it can induce a temporary diarrheal disease episode. It's a good laxative, actually. It's just like prunes. It's got the same ingredients as prunes. So the monkey then, having fed until they're so full they can't eat anymore, moves to another tree, all right, just to relax. And as they do so, and they're just sitting there and they're just talking, and how'd you like those figs? They were great. Oh, geez, I hadn't had big figs like that in a long time. And as they're doing this, they're urinating and defecating at the same time. So the seeds of the ficus, tropical ficus tree, have to pass through the gut tract of the bat or of the monkey in order to germinate.
Right.
So the feces then falls down through the canopy, and in doing so, some of it hits one of the branches and sticks, just like you could imagine.
Sure.
And there are the seeds with the nutrients that it needs to germinate and start its growth. So from the branches of these trees, they're called dipterocarps, okay, for the general term of tropical trees. Down from the branches of the dipterocarps come these tendrils of the ficus. They're getting all their energy from the energy of the fecal deposit from the monkeys. So they don't all succeed because of the amount of feces varies, right?
Right.
But the ones with a lot of feces to supply enough nutrients so that the ficus can reach the ground. Once they reach the ground, they can dig their roots in. And because tropical soils are so shallow, the root systems spread out from that point on. And now all of the nutrients that used to go to the big tree start going to the ficus as well. And the ficus, they form a circle around the big tree. And eventually, as their growth increases, they exceed the nutrient limits for the parent tree that they're growing on. And they end up making this amazing sort of an interlaced cage which traps the dipterocarp and eventually leads to its death.
Dipterocarp.
Yeah. That's the general term applied to these tropical trees.
So the ficus is a parasitic?
It's a predator. It's a predator tree. It actually replaces, and that's how you get a new fig tree.
Right.
It's amazing. It's quite amazing. And so you look at all these relationships. I'm sorry, I didn't mean to interrupt your reading of the letters.
I was looking it up. I was trying to find it, but that's cool.
Yeah, it's very cool.
I think people like when you digress.
Yeah.
Mike writes, Dear Doctors Racaniello and Despommier, I just wanted to write in with a bit of praise. I have been a regular listener of TWiV for over a year now, and I'm just catching up with TWiM and TWiP. I have to say, after having listened to the episode on hookworm and the remarkable backstory given by Dickson about that organism in a historical context, I am truly impressed. I spent 10 years reading about history outside of school in my youth, and I must say that I am deeply impressed by both the depth and breadth of Dickson's knowledge.
Oh, that's very complimentary.
Feeling good?
I'm feeling good. So if he wants to read more about that,
I
have a new book coming out.
We'll plug that.
Which we could talk about afterwards.
Okay. Thank you both for a wonderful show and the hours and hours of edutainment, Mike.
Edutainment, I like that.
Suzanne writes, R.E. earthworms. Remember?
I do.
I asked you why they came out after the rain, right? Here's what Suzanne says. They come out when it rains because they can.
Oh, right.
Not so much that they avoid wet tunnels when it rains as they usually avoid dry ground. When the ground is wet, they can come out, so they do.
Voila.
And they don't want to come out on dry ground.
No, I don't blame them.
So, does that make sense?
It's like eating crackers in the desert.
They'll dehydrate. Jeff writes, Hello, TWiP hosts. I just listened to TWiP 52, and all the emails had to do with you guys mentioning stopping TWiP. I just discovered TWiP last summer, 2012, and I've caught up with all the episodes. I just wanted to let you guys know that TWiP has kept my mind constantly busy during half-day hikes in the Pacific Northwest Cascades.
Oh, that's a lovely place.
I thoroughly enjoyed the rapport Vincent and Dick have. I love the jokes. It is one of my favorite podcasts.
Great.
I was trained as a chemist at San Diego State, so I have a special connection to TWiM with the SDSU hosts that are off and on there. I now live near Portland, Oregon, and hike quite frequently. I hope none of the twees die, and I thank you, too, for all your work and information you've given to thousands of people. They die when we die, right?
That's right. No, they can replay them, I guess.
This is from Rick. Hello, Dr. Racaniello and Dr. Despommier. I, like many, had a sinking feeling in my stomach when canceling the show was proposed earlier. I was refreshed to hear this will not happen. Dr. Despommier, do you know the Komuniekis at the University of Toledo?
Very well, yes.
I had the opportunity to do some work in her lab, Patricia, working with Ascarisum.
Great.
The trips to the slaughterhouse. If I may make a suggestion for a TWiP, TWIM, and TWiV drugs. Review of antiparasitic agents and resistance mechanisms.
We just did one of them today.
Likewise, antibiotics and resistance mechanisms.
Sure.
The new Delhi metallobeta-lactamase, CFR resistance, ERM resistance, efflux pumps, gyrase mutations, and everything TB has. What a show that would be.
Hey.
Shows. TWiV, well, I know there are not as many antivirals for non-retroviral infections, but why not? Then again, there's no shortage of TWiV episodes. Sorry, Dr. D. Thank you so much for all the education and the history lessons. I'm always captivated by Dr. D's stories. Best regards, Rick in Toledo, Ohio, patiently waiting for spring to come. Should be there now, right?
It's a longer wait in Toledo than it is in New York.
Spencer writes, Spencer is an MD, PhD. Dear Vincent and Dickson, attaches a letter which I think represents a sad state of affairs for parasitologists, epidemiologists, physicians, and particularly for patients. It is a decision probably driven purely by cost. In the past year, I have treated a patient at this hospital with amoebic dysentery. Was this patient part of the 0.3%? Could you address the quoted statistic about the overwhelming Giardia cryptosporidium being found nationwide? So let me read you this letter.
Sure.
It is on the letterhead of the Centra State Medical Center in Freehold, New Jersey. And it's dated April 16th, 2012, and it's to the medical staff from the medical director of laboratories, RE, ova, and parasite testing in the lab. As of Thursday, April 18th, Central State Laboratory will no longer be performing routine ova and parasite testing. Evidence-based studies show that 99.7% of samples tested in the United States are positive for either Giardia Lamblia or cryptosporidium. In the past 10 years, the only parasites we have detected at Centra State are Giardia and crypto. With this data, the lab will perform only the direct fluorescent antibody test for cryptogiardia and discontinue performing the microscopic ova and parasite examination. Detection of antigens on the surface of organisms in stool specimens is the current test of choice for diagnosis of Giardia and provides increased sensitivity over microscopy techniques. These tests also offer the advantage of short test time and multiple results in testing procedure. If a doctor has reason to believe his or her patient is infected with a different parasite, example, recent trip outside the country, we will send the specimen to Quest Diagnostics with pathologist approval. Do you have any opinions on this, Dickson?
Plenty, yeah. So
99. What is the number? Is that true?
Well, in that particular hospital, for that particular local population, that is true.
99.7% of samples tested in the U.S. are positive for Giardia or crypto? Is that true?
I think the results are misleading. You should go to the CDC for the statistic on this. But I think what they're trying to say is that of the patients that they have had stool exams done on, these are the two most commonly occurring parasites.
Right.
That's what they're saying. So why don't we just test for those two and not test for anything else? Because we're not going to find anything else most of the time. Well, I know it's expensive to maintain technologists that have skills at these levels whose only job is to do that. But what I would suggest in this case is to triage the work, all right, and to say a technician that's got multiple skills should rotate through the parasitic disease laboratory, diagnosis laboratory, I should say, and play a role in helping to keep up with the volume of stool samples that are sent there. Quest laboratories and other laboratories throughout the country are variable in terms of their ability to diagnose parasitic infections. Some are better than others. But by the way, what I didn't get a chance to refer to in our case that we just discussed on Blastocystis was that if physicians that see patients suffering from diarrheal diseases and do not find a causative agent with the first stool sample, they're obliged to look at another stool sample. And if they don't find it in the second stool sample, they're obliged to look at a third stool sample. You don't just find it on one sample usually. So the odds are, and we used to review this in the course that I taught here to our medical students, is that On one examination, the odds of finding a parasite that's low in numbers is less than 20%. Mm-hmm. All right, that was the odds. Because how did they get that odd? They did 3 in a row, and on the second stool, if the odd parasite was still there, the odds went up to 50%. And if it was not seen on the second stool, the odds went up to 70% diagnosis for 3 stools. That is to say, you can even find rare parasites 70% of the time if you do 3 stools collected day 1, day 2, and day 3. Most physicians are not that diligent. They do 1 stool sample, they send it off, comes back negative. That's not, you don't have that. Next. Right. And you can't do it that way, because if you do it that way, you're not paying attention to the variability of the numbers of organisms in your gut tract that can vary over time. Right. So it's a complicated issue that can't be solved by hospital administrators that are only driven by the budget. You're doing your general patient population a disservice by eliminating this ability to make the diagnosis over time.
I found a website called giardiasis.org.
Yeah.
Prevalence in the U.S.
Yeah. It's not 99%.
Ranges from 2 to 7%.
That's right. And mostly in daycare centers and little kids.
And in developing countries, it's 20 to 30%. But 97% is way wrong.
No, what they meant to say, what they really meant to say was of the diagnostically positive stools that we diagnosed in our laboratory in Freehold, New Jersey, 99% of them had Giardia and the other had Cryptosporidium.
It says here, evidence-based studies show 99.7% of samples tested in the U.S. are positive for either Giardia or Crypto.
So I suggest strongly that this individual who sent us this letter should go to their administrator who wrote the letter and say, you don't know what you're talking about. Where did you get your numbers from? But, of course, that's one way to get fired. I'm sorry to say this, but that's a very misleading statistic.
All right, the next one's from Frank. It's 50 degrees and sunny today in central Illinois with plenty of flooding in low-lying areas.
Yeah, exactly.
I would like to start by saying thank you for the 3 TWiP podcasts. I enjoy listening to them during my commutes, and while I am out walking, they are helping to keep my skills in immuno, micro, etc., while I am busy with my medical school studies and many other topics. I want to point out one clarification that applies to this week's TWiP number 53. You stated that a positive PPD indicated an active TB infection. It actually indicates that the patient has been infected with TB at some point.
Yeah, I agree.
Yeah. I think I said that. I'm wrong,
well,
most individuals
but I agreed with you.
that are PPD positive will not develop active TB unless there's an issue with their nutrition or immune system.
Right. It's difficult, though. There is an interesting point here, though, isn't there, Vince? Because we all know that if PPDs are positive, it means you've been exposed to the organism. Right. It's sitting in your lung in...
Gone complex.
In a tubercle.
Remember the Gone complex?
Yeah, I do.
He says here the active disease is when there's clinical or radiographic evidence of disease. Without either of these, the patient at worst has latent TB. This is important to know because latent TB is virtually non-transmissible.
Right.
It's also important to note that some patients with HIV and other immune disorders that affect the T-cell population will not react appropriately to a PPD test due to a lack of T-cells that cause the skin reaction.
Here.
P.S. I will be at the ASM conference in Denver. Do you know when and where you will be recording any TWiXs?
Oh.
We'll have a TWiV and a TWIM at ASM Denver.
Nice.
And the TWiV...
When is that meeting, Vince?
It's coming up towards the end of May.
All right.
And the TWiV will be recorded on Sunday, May 19th at 3 o'clock p.m. in meeting room 102. And I believe the TWIM will be on Monday at the same time, 3 p.m. in the same room, 102.
Wish I could join you, but I will be in Holland.
Perhaps you will meet me next year in Hamilton, Montana.
I know I will, Vince. I know I will.
All right, one more.
Sure.
From Justin. Sorry, 2 more. Marcel writes, hello, TWiP team. I love your family of shows, but while listening to TWiP 53, I noticed that Dickson used the word Eskimo. I hate to play politically correct police, but Eskimo is now considered as fairly derogatory, at least in Canada and Greenland. The word meaning eaters of raw meat by some accounts has been replaced here by the word Inuit. Just something to consider. Love the show. Marcel in Canada.
I apologize to any Inuits who I referred to derogatorily as Eskimos.
But none of them probably listen, but we should apologize.
Well,
anyway.
I will make a generic apology. I attempt in every respect of my teaching efforts to not offend, but rather to inform. So if this is part of that, I take it to heart and will never refer to Eskimos again as Eskimos. I will refer to them as Inuits.
Okay. Last one from Justin. I bought some crabs from a local grocery store and noticed these small black ovals the size of sesame seeds on one of the legs, and I was hoping you could identify this and confirm it's normal and an ectoparasite. Love the show. Thank you. Here you go, Dickson. These do look like bugs. Let me turn this around. No, you see them?
Yeah,
that's a crab leg, and there's a quarter.
Yeah. I think these are eggs of mollusks.
Why didn't they scrape them off? Because they can't be bothered.
They could scrape them off and look.
Look what's left when they scrape them off. There's a little image of the. Well, they could wash it. But
I hope there's no these. Yeah, these usually turn out to be eggs of mollusks of various kinds.
Yeah. But so are they ectoparasites?
No, they're
just eggs.
They're just hanging on. They're not deriving anything from the host. The host is called a paratenic host. What it does is it transports the mollusk eggs from one place to another. Fish get these too periodically in freshwater.
And this is not a problem. No, we just scrape them off before you eat it, right?
Oh, you wouldn't eat the outside of a crab anyway.
No. I mean, you could imagine one falling into the meat and you eating it by mistake, but it wouldn't matter.
If you cook it, you're going to kill them. You're not going to eat it raw, I hope.
So what are those eggs of? Fish?
Mollusks.
Yeah. I'm going to put that picture up, and maybe others can look at it.
Let's get a confirmation of this.
Maybe
sure.
Tommy can look at it. Hey, Tommy down in
This is my guess.
Australia.
My guess is this is the egg of a mollusk.
By the way, I'm visiting Australia in 2014, July. Yeah. Tommy, let's get together. I want to do a series of podcasts.
You will love that country. Vincent, you will just love it. I spent some time there, and it's a great place to go to.
This episode of TWiP will be, there's Dickson looking at the
there goes the AWACS.
AWACS is going down.
Back down.
This episode of TWiP will
aren't
be
we going to talk about my book?
Oh, I forgot.
I didn't.
Sorry.
No, I would like to.
Dickson, I understand your book is being sold now.
Thank you.
Tell us about this book. What's it called?
It's called People, Parasites, and Plowshares, and I think I've mentioned it before in the writing stages, but what I've tried to do is to accumulate episodes of long-lived parasites. And I've described much of the same things that I've described here orally. I've done this now in words to put down some of these stories. And then at the end of it, I speculate, and notice it's all speculation from my perspective, so take it with a grain of salt, as to how these parasites manipulate the host in order to live long lives and prosper, basically. Okay, so
live long lives and prosper.
That's right. That's
Very
right.
Clever, Dickson.
Well, that's okay. I think I told you this a couple of weeks ago. I met Leonard Nimoy at a restaurant.
You told me, but
by accident.
Tell the audience.
No, I actually got to say hello to him because he's one of my all-time heroes. So that's right, and he did that to me. He actually forked his fingers and gave me the live long and prosper sign because he was pleased to know that somebody there recognized him.
I'm sure he gets recognized all the time.
He does, but he's kind of a recluse, by the way. Okay, so fine. So this book was commissioned by Columbia University Press,
right,
to sort of allow us to go beyond the science and to sort of speculate as to how this might play out if. Mm-hmm. Okay, so the last part of each chapter is called Plowshare Concept. And within it is the microbiology or molecular biology of how the parasite seems to be able to hold on for such a long time. God bless you.
Excuse me.
God bless you.
I'm a little.
You should see a doctor.
A little tickling in my nose. No, it's the pollen in the air.
Oh, got it. So at any rate, I mean, I don't mean to dwell on this too much, but the book is now available on Amazon, and we look forward to your critiques of its contents.
We'll put a
link.
We'll put a link on the TWiP homepage.
Yeah. Now, you can't buy it yet. You can only buy it as of July 16th because it's now being offered as a pre-sale. And, it's not an expensive book. It's not like one of these giant tomes.
$20.
You can get it for a discount. Yeah, it's not bad at all.
Yeah, check it out. I've heard Dickson read it. It's cool.
Yeah, not only did you hear me read it, you actually read it.
I did.
You did. You were one of my advisors. Come on. So if anything is wrong in this book, it's all his fault.
Buy it. It's cool. I should write one with viruses in mind.
You should.
Someday.
You should do this, Vince.
All right. This episode of TWiP is going to be found at microworld.org/TWiP and also on iTunes. If you like what we do, you can help us by going over to iTunes, subscribing if you can. But if you can't, just leave a rating, stars, a comment or two. That helps us to stay visible because we want more people to discover us and learn about the world of parasitism. Isn't that right, Dickson?
That's exactly right.
And we love to get your questions and comments. Send them to twip@twiv.tv.
Right.
Dickson Despommier is at Racaniello.org, verticalfarm.com, and medicalecology.com. Thank you, Dickson, for today's episode.
It was great. Loved it.
Always nice.
Yeah.
And I am Vincent Racaniello. You can find me at virology.ws. The music that you hear on TWiP at the beginning and end is composed and performed by Ronald Jenkins. You can find his work at ronaldjenkins.com. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP is parasitic.